Good morning student. Today I am going to start the new topic equations of rotational motion. Okay. So as we know that in linear motion there are mainly three equations of motion. V equal to u plus at, s equal to u plus half at square and v square equal to twice as. But in case of rotational motion the equation is different. The main equation of rotational motion is given. First equation, omega equal omega naught plus alpha t, and second, theta equal omega naught into t plus 1 upon 2 alpha t square, and third one is omega square equal omega naught square plus twice alpha theta. So let us first know what is the meaning of this symbol. Okay, so here omega naught is initial angular speed, omega equal final angular speed. Okay, alpha is angular acceleration, t is time, and theta is angular displacement. Okay, so theta angular displacement, omega final angular speed, omega naught initial angular speed, alpha angular acceleration. Okay, so let us now just revise this term. The rate of change of angular displacement is known as angular velocity. Its unit is radian per second. Similarly, alpha means angular acceleration, means rate of change of angular velocity is called angular acceleration. Its unit is radian per second square. Theta is angular displacement. Angular displacement means angle equal to arc upon radius. Okay, and t is time. Its unit second. So these are main three equation of rotational motion. So here now we are going to prove this equation one by one. So let us now prove the first equation, omega equal omega naught plus alpha t. First equation of motion is omega equal omega naught plus alpha t. Okay, so according to definition of instantaneous acceleration as angular acceleration. Alpha equal d omega upon dt. Okay, now cross multiplying d omega equal to alpha dt. So here d omega and dt is integral coefficient, so integrating both sides, okay, so integration sign d omega, then lower limit omega naught, final limit omega. Okay, this is omega equal to alpha is the constant taken outside, integration sign and dt. The limit of time, lower limit means 0 and upper limit t. Okay, of the omega is omega. Now the limit, lower limit omega naught, upper limit omega. Okay, equal sign alpha, integration of dt is t, limit 0 to t. Now substitute the limit, upper limit minus sign, then lower limit. Okay, equal alpha here upper limit minus lower limit, then omega minus omega naught equal to alpha t. Now transfer this omega naught to right side, so we get omega equal to omega naught plus alpha t. So it is the first equation of rotational motion in which omega is final angular velocity, omega naught is the initial angular velocity, alpha angular acceleration and t time. Okay. Second equation of motion is theta equal omega naught t plus 1 upon 2 alpha t square. Okay. According to definition of instantaneous angular velocity, okay, omega equal to d theta upon dt. Now cross multiply, d theta equal to omega dt. So as we know that omega equal omega naught plus alpha t. So d theta equal to omega naught plus alpha t in a bracket, then this dt same. In that line, open the bracket, omega naught dt plus alpha t and dt. So d theta dt is the integral coefficient, so we have to integrate both sides. So integration sign, d theta equal integration omega naught dt plus integration sign alpha t and dt. Now put the limit. In case of time, lower limit t, upper limit t, lower limit 0, upper limit t. In case of theta, lower limit 0, upper limit theta. So as we know that the integration of d theta is theta. Okay. So now put the limit 0 and theta. Similarly, omega naught is a constant, so taken outside, and the integration of dt is t. Here limit 0 to 2, 0 to t, same, plus alpha is a constant taken outside. Then t dt means t raised to power 1 dt. Okay. So when we apply the formula, then t raised to power 1 plus 1 upon 1 plus 1. It means t square upon 2, limit 0 to t. Right. So now substitute the limit, upper limit minus lower limit equal to omega naught, upper limit minus lower limit plus 1 upon 2 taken outside alpha, then substitute the limit t square minus 0 square. Okay. In next line, we can write theta equal to omega naught t plus 1 upon 2 alpha t square. It is the second equation of rotational motion. In this equation, theta is angular displacement, omega naught is the initial angular velocity, alpha angular acceleration. So theta equal to omega naught into t plus 1 upon 2 alpha t square is the second equation of rotational motion. Okay. Now third equation of motion, omega square equal to omega naught plus twice alpha theta. So according to definition of instantaneous angular acceleration, alpha equal to d omega upon dt. Okay. Now multiplying and divide by d theta. Okay. In d theta, here d theta. Now d theta upon dt is equal to omega. So we can write omega into d omega upon d theta. So here we can write d theta upon dt is equal to omega. Okay. Now cross multiplying, omega d omega equal to alpha d theta. So d theta and d omega is the integral coefficient. So we have to integrating both sides. Okay. Integrating both sides. So integration sign, omega d omega equal to alpha is the constant taken outside here d theta. Now put the limit, lower limit 0, upper limit theta. Here in case of angular velocity, lower limit means omega naught initial angular velocity and omega final angular velocity. Now apply the formula. As we know that the integration x to the power n dx is equal to x to the power n plus 1 upon n plus 1. Here power is 1, so we can write here 1 plus means 2 upon 2. Okay. Limit omega naught to omega equal to alpha. Now in right side the integration of d theta is theta, lower limit 0, upper limit theta. Now substitute the limit, so 1 upon 2 taken outside. Now upper limit minus lower limit equal to alpha, upper limit minus lower limit 0. Okay, so 2 send to right side, so omega square minus omega naught square equal to twice alpha and theta. Okay, omega equal to omega naught square plus twice alpha theta. It is the third equation of rotational motion, right? So in this equation, omega is final angular velocity, omega naught initial angular velocity, alpha angular acceleration and theta is angular displacement. Okay.